Okay, so we talked about just converting from one unit to another unit, and maybe I will have my little scrap piece of paper, right? So we converted, from feet to meters, for instance, or from miles to centimeters, right? Depending on what was placed upon us. We could go from pounds to grams, you name it, right? So we did that at first, and then we talked about a rate, you traveling 50 meters in 20 seconds, right? That is a rate. So we talked about rate. And then the unit rate of that would be, dividing both of them by 20, and you would get a distance that's 5 divided by 2, that's 2.5. 2.5, yeah, 2.5 meters per second. This would be a unit rate. Okay, so they're basically saying the same thing, but sometimes when you're comparing or wanting to know the best, which one is faster, what's the best deal, and so forth, we want to have them both in unit rates and both in the same units as well, right? And so we learned how to convert that, and always canceling out units by placing them on opposite ends, right? Like if you want to cancel the meter that's on top, then you have to have a meter at the denominator on the second conversion ratio so that you can cancel out those units. Okay, so we've talked about that. Um, and so what we're going to do to start off, okay, I will do the attendance in a bit. I made a short AC, which is on. It's going to be a Google form. You will just basically make sure you do the work on loose leaf on the side, just in case it crashes on you. Okay, so we'll do that AC on Google form, and then we'll continue with our notes. Okay, so AC Google form, which I will put it under class work right now. I'm just writing this down. Sometimes students join a little later. So I'll pause the recording. You do that. It shouldn't take you, I'm thinking 15 minutes, so 2:30 we should be done. So for scale factors, it's similar to scale diagrams, but it's written differently, okay? So the scale factor, and it's denoted by letter K, it is similar to a scale, comma, but is written as a fraction and has no units. Okay, it's a fraction and it has no units, okay? So we can convert from a scale, which you've been working with, right, which we talked about yesterday, and you can convert that to a scale factor, okay? And obviously a scale factor can be written as a fraction, decimal, or percent. Okay, so obviously we know that we can convert in between, okay? But normally we like to write it as a fraction. It doesn't have to be. It can be in one of these three formats. But it is not written as a ratio, where you have number, dot, dot, another number. You don't write it like that. K is usually the measurements of the diagram over the actual, okay, the measurements of the actual, okay? Or we can also write K as new, like the dimensions of the new one if you're making a copy of something, and original. Okay, so when you're making a copy of something, you might want to just refer to this is the new, right? The copy, and this is the original, the one you started off with. When you're looking at a picture and a picture of something, right? There's the actual and the diagram, which is what we consider our picture. Okay. And so here we have it. For example, converting a scale to scale factor. So example, we have 1 centimeter is 23 meters. Let's say you have something like that. That's just a classic scale. Okay. If you want to convert that to a scale factor, okay, what we would do is we would say, hey, K is equal to, and remember that diagram is always on top, actual is here. And which one of these was the actual again? It's this one, actual, and this is diagram. Just go back to yesterday's notes and that would be the case. So now that we're writing it as a scale factor, we want the diagram measurement on top and the actual and the denominator. But notice that the units are different, right? So we need to convert. Because ultimately what we want is the units to be the same so we can cancel them out. Okay, so what I will do is just underneath it, I will say that K is equal to 1 centimeter over 2300 centimeters. And this is just assuming that right, there's 100 centimeters in 1 meter. So you just multiply that by 100. If you want to do the conversion on the side, that's fine. But now that the units are the same, we can cancel out centimeter with centimeter and are just left with K is equal to 1 over 2300. Okay, and that is as a fraction. We can also write it as a decimal. So let's go ahead and do that. We just go 1 divided by 2300. And that is a really small decimal, right? That's okay. 0, let's go 4 decimals here. 0.0004. That's why I prefer to keep it as a fraction, because if you keep something as a fraction, just like system of inequalities, right? Just leave it as a fraction and then it's more accurate. But this would be the decimal. If you want this as a percent, watch what do. I don't take this one. I take what's still on my calculator. You just multiply it by 100, which will really just bump the decimal up 2 spaces, and then it's 0.043%. I'm using 3 decimals there. So every single one of these is technically correct, right? But I prefer this. Preferred is the fraction. Okay, so what have we done? We went from a scale to a scale factor, ultimately without units. Okay, and if these two had the same units, if they were both centimeters, it would have been very easy. It would have just been plug it in, cancel the units, and then you're done. Okay, so just keep that in mind. So here I want to talk about the different, if K is, okay, you have a couple of options, right? Greater than 1. If K is greater than 1, so basically K is greater than 1, we can put that here in the in brackets, right? That notation. Then how do I put this? That will result in an enlarged version of the original or actual. Okay, we kind of call them the same. So if K is bigger than 1, then the diagram or the new object is going to be larger than the original or the actual. Okay. If K is equal to 1, K is equal to 1, no change. The new object is exactly the same. Okay. If K is less than, results in a reduction or reduced reduction of the original slash actual. Highlighter, K greater than 1, enlargement, K is equal to 1, the same, K is less than 1, it's a reduction. Okay. And it's always, we always refer to the original or the actual. Okay, that's how you always refer back to. It's like, what happened to the original? Oh, K is greater than 1. Well, it was enlarged, right? What happened to the original? Oh, I end up with a K that's less than 1, 0.45. Oh, that means that the original, right, has been reduced to this, right? Or it results in a reduction of the original to that. Okay. So let's keep going, back page. This is already the back page, so I have to have a new page. Example, K is equal to 2/3, right? If K is equal to 2/3, that would result in a decimal of 0.67 or 66.67%. And that would be results in reduction of original. Okay, because it's less than 1. K is less than 1. Or you could say K is also less than 100%. That is the same thing. 1 or 100% would be the same thing. Okay. If K would be 5/3, let's say, okay, that is 1.67, which would be 166.67%. And if you're wondering, like, how come Mr. Dirksen doesn't just put 67%? that would be incorrect rounding because you always go back to the fraction, right? Like, for example, if I go 2 divided by 3, right? That is 0.67 of as a decimal, but if you multiply that by 100, it's 66.67%. So you always, it's kind of like we go from here to the decimal and then we go back to the fraction to get our percentage. If you go from 67 to 67%, that'd be rounding too soon, okay? That's what's happening here. Same thing with 5 over 3. This is an enlargement of original. K is greater than 1, or you could say K is greater than 100%. And we have, what if K would be 380%, for example? K would be 380%. What would you do there? You could turn it into a decimal, dividing that by 100, so that's 3.8, right? You could also write it as a fraction if you'd like, and it's 380 over 100, right? Because that's what percent is. And you can cancel the trailing zeros, and that'd be 38 over 10. And I'm not going to ask you to reduce, but it's still good practice. So dividing that by 2 would give you 19. Dividing that by 2 would give you 5. So technically, the scale factor as a reduced fraction would be 19 over 5. But if you convert it to a decimal, that's just fine. But this would still be an enlargement of original because K is greater than 100%. Let's just talk about percentage, or K is bigger than 1 if you look at it from a 3.8 perspective. Okay, so here we go. Convert the following scales to scale factors. And this skill right here will not per se be asked of you, but when there are word problems, you're going to have to be able to do that to go from a scale to a scale factor. So A would be 1 centimeter to 15 meters, and B would be 1 meter to 25 meters, and C would be 50 millimeters to 2 centimeters. So we're going to convert the following. And you have to see that there's a relationship between scales and scale factors. For example, you can just look at a scale and determine whether it is an enlargement or a reduction, okay? Simply by looking at, and I talked about this yesterday, you start on the right and see from here to there, is it going up or down? Well, 50 meters is a lot bigger than a centimeter, so you know that this is a reduction of the original. Again, start here, from 25 meters to 1 meter, it's still going down, right? And so that's that. From 2 centimeters to 50 millimeters, there you have to be a little careful. 50 millimeters is what? 5 centimeters. So going from 2 centimeters to 5 centimeters, you're actually going up. So that will be an enlargement of the original. So you should still be able to see that as we're doing this. But we want everything as a scale factor. So remember, scale factor, no units, and written as a fraction if at all possible. Okay, if you write it as a decimal, unless I specify it, if you write it as a decimal, as long as it's rounded correctly, it's still okay. So we'll go 1 centimeter over 15 meters. Units are different. So you say, hey, that's the same thing as 1500 centimeters, right? Just on a side, let's do a side here. 15 meters, multiply, right? You know that 1 meter has 100 centimeters. You cancel out the meters, right? It's 15 times 100. That's where the 1500 centimeters come from. Okay? And so now that the units are the same, it's just 1 over 1500. And we'll leave it at that. Okay? If you were to write it as a decimal, that'd be 0.0007, right? 4 decimals there. Let's write this as a scale factor. It's 1 meter over 25 meters. Your lucky day, right? Units are the same, so it's just 1 over 25. That we can write as a decimal, right? That's 0.04. And let's also go as a percent. You just multiply that by 100. Okay. Next, K is, and it's always the left number goes up top and the right goes at the bottom. So now it's up to you what you want to do. You want to convert the 2 centimeters to millimeters. It's probably easier, right? You go 2 centimeters times, I know that 1 centimeter has 10 millimeters. You cancel the centimeters here, and that's 20 millimeters. So we're going to replace 2 centimeters with 20 millimeters. And that would be 50 over 20. Cancel the trading zeros. That's just 5 over 2. And that's 2.5, right? 5 over 2. So K is 5 over 2 or 2.5 or 250% if you multiply that by 100. Let's go up and check. I'm going to use a different color. This, if just by looking at that, can you tell me if that's an enlargement or a reduction? K is less than 1 reduction of the original, that is. Okay. How many times has the original been reduced by? By 1500. Okay. 1500 times smaller. B, it's also, right, K is less than 1. You can clearly tell that here by the decimal. So it's a reduction. And then next, you want to look at this one. Here you can clearly tell K is greater than 1 enlargement. Enlargement. And then this is where it gets a little trickier. I'm going to use even a different color. Okay. It's a reduction by a factor of 1500. Okay. So forget about the 1. You just look at how many times has it been reduced. It has been reduced by a factor of 1500. On this one, you look at the fraction. You want the 1 on there, and here by a factor of 25. So B has been reduced by a factor of 25. And we're going to change the wording on purpose because sometimes it's easier to do so enlargement by a factor of, I'm going to go, you can go 2.5 or 250% or 250%. So whatever works best in that scenario, when there's a 1 in the numerator, right, then it's just easy to say it's a factor of 25. But you could have also said by a factor of, look back to B here, you could have put down a factor of 4%. That is fine. Okay. So percentage, decimal, fractions, you can use them interchangeably, and that is fine. Okay. Let's do some word problems. Here it is. The diameter of a cell is 0.25 millimeters. In a textbook, it is depicted as a picture measuring 3.5 centimeters. A, determine the scale. Used. B, state the scale factor. C, is this an enlargement or reduction? By how much? Write that down. Okay. So go ahead and write that down. And I want you to see the connection between a scale and a scale factor. It can be used interchangeably. In fact, sometimes you want to use a scale rather than a scale factor because sometimes it's not necessary to change the units, right? If a scale will have different units sometimes, and if you just flip them and state it as a fraction, and you know one of the other measurements of the actual or the diagram, then you can just cross multiply and divide, and the unit that you want, it's gonna be your final answer. Okay. So here we go. The diameter of a cell is 0.25 millimeters. In a textbook, it is depicted as a picture, in a picture, I guess it should be, in a picture measuring 3.5 centimeters. Determine the scale used. So let's answer A. When we're talking scale, we want diagram on the left and actual on the right. Or you can think of new and original. However, we're not making copies of an object, right? We're just talking about the same thing, but in different scenarios, okay? So the diagram would be your picture in this case. It would be that, the 3.5 centimeters. So we go 3.5 centimeters, make sure you add the units here, and your actual measurement of that cell is 0.25 millimeters, okay? And you're basically done. Okay, that's it. You don't need to convert. Um, some some teachers and other courses, I don't know what they're gonna be telling you. They might not like decimals. So what a lot of teachers will do is they will ask you to, reduce that. So basically, if you multiply both sides by 100, you turn this into 25, and this would be 350, right? And then you reduce it further that way. But I'm fine just stating it this way, okay, for our purposes. B, determine a scale factor. So you want to use the letter K, and we take the diagram, and you write down the units at first because we want to check to make sure they're if they're different, we need to do some converting so that we can cancel out the units, because ultimately we don't want units here. And so you decide what's easier. I think for my purposes, I would want to just say let's convert this to millimeters. Just multiply it by 10, so it's 35 millimeters over 0.25 millimeters. Okay, you can cancel the millimeters, and you end up with 35 over 0.25, just like that. And here is where, if I ask you to write a scale factor and I tell you I want it reduced, then your best bet is to divide both of these by the smallest value, okay? So I will divide, so it's almost like a unit rate. You almost want a unit rate. So you divide the bottom by 0.25, you divide the top by 0.25, and obviously you're going to get a 1 in the denominator, and you're going to get 140 in the numerator, which is just 140. I get it. Okay. What is it? 140 what? It's just 140, right? If you wanted that as a percentage, you would have to multiply that by 100, right? So you'd write, this is a fraction here, if you wanted to. This is what it is as just a number, almost a decimal, and then it would be this many percent, right? So what happened here for C? Is this an enlargement or reduction? Well, since K is definitely greater than 1, it is an enlargement of the actual by a factor of, and here you just grab in this case, you grab the 140. You don't want the 1, right? And 30 or 14,000%. There it is. Okay. Second example. the actual length of a pool is 20 feet, and its width is 15 feet. A scale model of the pool has a length of 30 inches. Is it 30 or 36? I have to read my notes carefully. 30. Okay. A, state the scale used. And we'll say reduced here. Why not? State the scale factor. How much larger or smaller is the model? Go ahead and write that down. Just 1 second here, folks. There. Hi there.
Hey there.
Just need to check the alarm or what?
Just put the sticker on there, that's all.
Okay. You can take the eraser off. I was just putting it on there while you were testing it today, just to not blast my ears. Yeah. All right. You can keep going. Right, so the actual length of the pool is 20 by 15, okay? The scale model is 30 inches. State the scale that has been used. So write it down. Again, for the scale, we want diagram to actual. All right, so the diagram in this case, the key here is to understand is that if the pool, right, think of a rectangular pool, and it's 20 feet long, 15 feet wide, right? And so you made a scale, you can probably tell it's a smaller version of it, and you're told that the length is 30 inches, you don't know what the width is, okay? But when you're making a scale of something, both dimensions, or all dimensions for that matter, have been adjusted by the same scale factor, by the same amount, okay? So here you go. We only have the lengths to compare. So the 15 is what I call too much information, right? You don't need that. So the diagram is 30 inches, and the actual length here would be 20 feet. There you have it. And they want it reduced, right? So we're gonna, for our purposes, right, we're gonna just keep that like that. Obviously, you could divide them both by 10, right? And it's 3 inches to 2 feet like that. That would be the reduced version, and it's fairly easy to do, right? B, state the scale factor. You can use either one of those. I'm going to use the 3 inches over 2 feet. Okay. We can't have different units, so we're just going to go 3 inches. 2 feet, I'm sure that you can all figure it out as 24 inches, right? It's just 2 times 12. You cancel out the inches like that, and you have 3 over 24, which can be further reduced to, right? The 3 goes in there 1 time, goes in there 8 times. So this would be the reduced version of that scale factor. Okay. C, how much larger or smaller is it? Well, K is less than 1, you can tell, right? Therefore, it's smaller by a factor of 8. Okay. So there it is. We decided that it was smaller. It's a reduction, right? Because K is less than 1. And that's what you get there. Let's just put down here as a fraction that K is 1 over 8, which is also 0.125, which is also 12.5%. So any one of these three could have been used here to answer C. Okay. All right, I'm gonna stop there and just give you the homework for this section. So we're gonna go back to page 479, which I already gave you two questions from that section already. So I will ask you to do 1, 2, 1 to 6, and we're gonna go 9 to 11. Okay. So that is the homework that goes with this section. And we'll do more examples tomorrow. Hopefully it will sink in a bit more. But make sure you give this a try, right? For you to understand the concepts, right? The answers are at the back of the book, and just go for it and see if you might have to go back in your notes based on what we did yesterday to help you understand, right? Because scale and scale factors are related, of course. Anyways, that's all.